presentation. Today, my topic is about welding repair of dragline bucket. So, firstly, let's see. This is a dragline bucket. As a mini excavator, the dragline bucket is easy to be welded since it had to dig its harness metal. And you can see that the size of the dragline bucket is so big. It means that its cost is high. So once the dragline bucket is welded, most of industry will repair it rather than replace it. So when it comes to repair it, welding technique as an economical practical skill has thousands of years development. Nowadays, the welding has become the most common way to repair the dragline bucket in the mining field. However, it's not mean that there is no any issue about the welding repair of dragline bucket. Residue stress. It is an unavoidable problem of the welding process. The residue stress formed by welding is also a significant problem. The welding process of steel structure, such as ship, bridge, excavators, induced residue stress and destruction which can affect the mechanical properties. The cause of the residue stress is because that unbalanced heat during the area of structure. Since the size is so large, it cannot global heat to repair the welding mass. It just can local heat. The unbalanced heat causes the unbalanced temperature path. Is the main reason of the residue stress. It means that the problem is unavoidable. PWHD is also called the post-welding heat treatment. It is a common way to reduce the effect of the residue stress made from welding elements. It is besides the PWHT, it's many other ways to reduce the residue stress. But for the large mining tools, the post-welding heat treatment is the most common ways. The PWHT from the microscope view, it means that meat slowly heats to a certain temperature, keep enough time, and then cooling at appropriate speed. The purpose is to improve the mechanical properties, and the rest is life cycles. There are various elements during the process of PWHT that can affect the final result of the post-welding heat treatment, such as the critical temperature, cooling weight, cooling speed. Even though the field material can also affect the whole process, it's complex. While when I read the relative literature, I found that there is real research about the critical temperature during PWHT. Most of the industries, according to their experience, to choose the critical temperature to reduce the radical stress. And in most of the literature, I read about the simulation experience about PHT. The evaluation condition is not correct, since most of experiments use furnace to heat the weld elements. Well, in fact, the dragline bucket is heated by its local heat, since it's too big. There's not enough big furnace for the dragline bucket. And another problem is that the material. Since in the past, the high manager steel is the most common choice for the dragline bucket, but nowadays, the low alloy and the low carbon steel has been the better choice for the bucket. So, for these two factors, I designed a new experiment for the topic. And first, the experiment. And first, the material of specimen is a Q345B steel, and it's with a thickness of 5 mm, and 5 mm, 5 mm. And the temperature range is from 500 degree to 700 degree. The duration is 25 degrees. And before the PWHT, all of them have to pass the test about the yield strength, the physical behavior. And after the PWHT, all of the properties had to be tested again to compare the results, to find the relationship between the temperature and the effect of PWHT. And on the other hand, the digital computer simulation is also be used during the experiment. We will use software to simulate the whole process, which including the reheating, welding, and the PWHT. We can compare two of the results to raise the accuracy of the experiment. One of the limitations of the experiment is that it just can research one kind of alloy during the experiment, and the strength of it can give a specific data and most formula about the relationship. That's all. Thank you.